There are several ways that chemists, or a scientist that studies chemistry, name different compounds. Okay? And they get very complex. If you have an older brother or sister and they've had to take like organic chemistry, you may have heard about that course that is really has a reputation of being super challenging and really hard, because one part of organic chemistry is often remembering about how to name and what the names of all of these different compounds actually mean. So we're not going to get into any detail at all. We're going to take a very simplified approach and just tell you a little bit about an example of how some of these compounds are named. So oftentimes, if you imagine like carbon dioxide or something, it's basically the first element of the compound. Okay, is the first word, so carbon dioxide, it's carbon. And then often I, the ending of the second element in the compound is changed to I. And so we have carbon dioxide. And then we use, so what's NaCl? Sodium, not chlorine, that's not its chloride. Sodium chloride. And we then will use Greek prefixes to tell how many of the elements there are. So CO2, carbon. What's the word we're going to use for the oxygen? Well, for the oxide, and there's two of them, so we call it carbon dioxide.
Oh, that makes sense.
Have you ever heard of the gas carbon monoxide?
Yes.
It's a dangerous gas. If it builds up in your house, for example. What do you think its chemical formula is?
CO.
Just CO. Monoxide, one oxygen.
Wait, that makes no sense. How is it dangerous if one oxygen?
Because it changes the property. So by changing the number of elements or which elements there are in a compound, it can drastically change the properties. Just like I told you the other day about sodium chloride. I told sodium, a reactive, dangerous metal. Chlorine gas, poisonous, will kill you if you were to inhale it. Yep. However, if we take this reactive, dangerous metal, combine it with this poisonous gas, we get salt that we put on our food. So the properties of a compound can be very, very different for the properties of the elements that make them up. If you look on your radical sheet, which you have, those radicals are also called polyatomic ions. For those, you probably noticed the endings they have endings in common. Like there's nitrate, there's sulfate, there's carbonate, acetate. Okay, those endings, there's nitrite, okay, there's sulfite, phosphite. Those endings mean something. So usually in those polyatomic ions, if they end in "ite," they have less oxygen in them. For example, look at nitrate and nitrite on your chart. What is nitrate? What's its formula?
CiO2.
Not for nitrate.
Oh, NO3.
NO3. And nitrite?
NO2.
Right, look at sulfate and sulfite. SO4, SO3. So those terms mean something. So what would we call this? Raise your hand. We already did this. Sodium chloride. MgO. Okay. Magnesium oxide. We typically omit that mono part if it has only one. How about MgBr2? MgBr2. Devin?
Magnesium.
You're close. What? Not quite.
Dibromide?
Magnesium dibromide. There's two bromines. Li2S. Raise your hand once you think you know the name of it. Hold on. Li2S. Mitchell?
Lithium sulfate.
Close. Sulfide. Remember, we changed the second word to an I. Dilithium, because there's two lithium. And sulfide, because we changed the element name to I.
So what if you put the S
That's
So
just
what
the,
do you mean to change the second one?
yeah.
So like to make it unless
All right. BeSO3,
You change it to I every time.
unless we get into these next few examples. BeSO3. Jake?
It's beryllium, I think. Sulfate?
Beryllium sulfide. Where'd you get sulfide, Jake?
On the red.
Yes, it's one of those radicals from our chart. SO3 is sulfite.
Oh wait, do you know that it's one of these when both of the letters are?
If there's several elements together. All right, ALBO 3. ALBO 3. Got it? Aluminum borate. Good.
oh
And the last one. Layla?
Calcium carbonate.
Calcium carbonate. Good. Let me give you one more example. Ca2I3. Ca2I3. Sage? Dicalcium? Try what? Iodide. Good. Dicalcium, because there's two calciums. Triiodide. Good. Nice job.
If we write light instead of I, wait, so if we write like instead of DE and we write TE.
That'd be wrong.
okay,
All right. So the last real topic for us to learn about is how we can determine the mass of a certain compound. We just did in our question today. So after, if you understood that, then the next examples are just a little more complex, but it's the same idea. So when we write these formulas for different compounds, we have some terms to use. So this number that comes before the H, that big 4, that's called the coefficient. So first of all, a compound is two or more elements that are chemically bonded together. Here we have hydrogen and oxygen chemically bonded together. This number that comes before it, it's called a coefficient. Just like in math. Do you use that term in math?
yeah.
All right. The coefficient tells us how many molecules of that compound we are referring to. So in this case, how many water molecules are we referring to? 4 of them. The small numbers that come after an element are called subscripts. What is this 2 referring to? Referring to the hydrogen. It refers to the element before it. And it's telling you how many atoms there are of hydrogen in this compound. So using these symbols, using coefficients, using subscripts, just allow us to sort of condense, make things more efficient when we're writing these formulas. For example, we could write 4H2O without the coefficient, but we would have to write it 4 times. We could write 4H2O without a subscript. We would just have to write the H twice. But we don't. We use these conventions to write the formula. So, when we want to know about a molecule, about a compound, we can figure out how many atoms of each element there are. For example, if I have Al2O3. So, we list the elements, so that's made of aluminum and oxygen. How many molecules of this are there? No. One. Just one. How do we know how many molecules there are? Where are we looking?
The coefficient.
The coefficient. And if it's not there, it means 1. How many atoms of aluminum are there?
5.
No.
No. 2.
There's 2 atoms of aluminum. So there's altogether a total of 2 atoms of aluminum in this. How many molecules of this whole thing do we have? How many atoms of oxygen?
3.
So there's 3 atoms of oxygen. So if I wanted to know the mass of this, which we're going to do next, what would you do? I want to know the mass of the Al2O3. How would you figure that out? You just did it for water in our question of the day. Danielle?
You find the atomic mass for both elements and then you add them together?
You're close. That's your first step. You find the atomic mass of aluminum. And then, Maddie?
That times the coefficients. Wait.
Close. Olympia? You multiply this number by the atomic mass, and then you multiply this number by the atomic mass of oxygen, and finally add them together. That will tell you the mass of an Al2O3. Now, sometimes when you're doing these problems, you might have a group of atoms in parentheses, like NO3 parentheses 3. That can be a little bit confusing sometimes.
Not really.
All right, what does this 3 go with? No, it only goes with the oxygen.
Isn't that
Where does this 3 go with?
I know.
The entire thing.
Oh my gosh. But isn't that one of these?
So the first subscript applies to the oxygen only, the second one to the entire molecule.
It's nitrate.
So if I look at this, how many atoms of nitrogen are there? No. How many?
0.
Nope.
How many atoms of what?
How many atoms of nitrogen?
3.
I hear competing answers. Who's confident in their answer and can explain why to me? Max?
3 because there's a 3 outside the parenthesis.
And does this 3 go at the end?
Yeah.
It does. How many atoms of oxygen? Raise your hand, please. How many atoms of oxygen is there here? Caitlin? No. Jack? 9. There's 3 times 3.
Oh my gosh.
So there's 3 of these. So that's 3 times 3 is 9. All right, let's do this one. Now we got a little bit of a challenge. So how many molecules of this thing are there?
3.
3. I look at the coefficient. How many hydrogen atoms?
3.
What's the subscript? 2. So how many total hydrogens?
6.
6. Oh, you have to move
3 times 2 is 6.
go over the 3 part.
What? This 3, what's it go with? Only what's in parentheses. All right, how about the carbon? First, how many molecules?
1. 3.
3.
That goes to everything.
That goes to everything. The coefficient goes to everything. What's the subscript? Inside. 1. What about outside?
3.
3. Total number of atoms? 3 times 1 times 3.
Why is it 1 times 3? Because what's the 3?
There's a 1 inside the parentheses, but there's also this 3 outside the parentheses. So we multiply the coefficient times the subscript times the subscript. How about oxygen? Number of molecules, 3. Subscripts?
3.
Inside it's 3. Outside it's 3. Total?
27. You can't math.
27.
Oh, I'm 8. Oh, wow, I am not smart.
So we getting there?
Yeah.
All right, let's look at some of All right. If I asked you to find the mass of this whole thing, could you do it?
Yes.
Tell me what you would do.
Add all those.
Hold on, Sophia? Of each element, yeah, so this. Where's the mass come in? Layla?
Okay, so you take like each element, the number of atoms, you take 6 times the atomic mass of hydrogen, which would still be 6, plus 9 times the atomic mass of, what's that?
Carbon.
Carbon, plus 27 times, wait.
Mass of oxygen.
Yeah.
Add them all up.
Together.
That's the mass of this whole thing.
500.
And that's what we're going to do next. We got that. All right, let's look at this one, a simple example. So, we're going to look at this, sodium nitrate. So, what atoms are there? What elements do we have? Just list them. What are they? Sodium, nitrogen,
Oxygen.
and oxygen. Those are our 3.
Yeah, because.
Those are our 3 elements.
Oh, yeah.
How many molecules of this whole thing are there? How many molecules?
1.
Just 1. There's no coefficient, that means 1. So, how many atoms of sodium?
1.
Just 1. How many atoms of nitrogen?
1.
Oxygen?
3.
3. Atomic mass of sodium? Where do you get it?
23.
Where do you get it? It's on your periodic table. It's 23. Atomic mass of nitrogen?
14.
And oxygen?
16.
Yes, no? What do I do here? What is the mass of the sodium? 1 times 23. Nitrogen?
14.
And oxygen?
42.
No, 48.
3 times 16 is 48. And how do I find the total mass?
Add them up.
Add them all up?
30, 60, 70, 80, 82. 85.
85. This is why we need our calculator in class.
I have mine just too easy. I do too. I just like.
All right, super simple example, HCl. You guys can do it. Go.
Hydrogen chloride.
Do it quiet.
Did I get it?
I don't know. Everything broke.
That's CL.
Oh, okay. Wait,
Adam.
what? Then Adam?
Isn't it 111?
Yeah.
Isn't it 111? And then it's
I did it.
All right.
Wait, I'm almost done.
All right. Well, we can.
Wait, where's the, C, huh? C?
Three numbers. Where?
Okay, here we go.
Wait.
What are the elements?
Wait, is that supposed to be hydrogen?
Hydrogen, what are the elements? Hydrogen and chlorine. How many molecules of this are there? Just one. How many atoms of hydrogen? Chlorine? Atomic mass of hydrogen? Kind of boring. Chlorine?
3-5.
Mass of hydrogen? Mass of chlorine? Mass of the whole thing? Atomic mass units. Good. Alright, this is too easy. Skip it.
No.
Here we go. Let's see. Can we do this? Yes, you can.
Bro, we only got like 2 minutes. Bro.
Have confidence in your.
Cannot do it.
Alright, shh, go ahead.
It's disgusting.
Wait, what? Oh, I thought you were
I did.
I can't find it.
No. Whoa. That was some gaming.
Isn't that homework?
Yes, sir. Yes, sir.
This, I don't want this.
Yep, what I just gave you is your homework. Keep working though. We still got 2 minutes to get some practice in.
Oh my god.
In 12 times 6.
Yes, sir. 12 times 12 times 12.
Oh yeah, you have to. I need help.
Almost ready for me to reveal it?
No.
I am.
Yes, sir. I don't.
First one? No, not the first one. Too easy.
Is this
Second.
big? It is pretty big.
All right, let's check. Hold on, check your answer. Oh, we have carbon, hydrogen, oxygen.
Wait.
There are 4 molecules of the entire compound. All right. So 4 times 12 is 48. 88. 44. You could do that math separately. It's up to you.
I did it.
Atomic mass of carbon is 12. Hydrogen 1. Oxygen 16.
Why is it 88?
You didn't do anything.
Because we have 4 times 22.
Oh, I just did it like.
You could split it up, that's fine. As long as you end up with the right number, that's fine. Multiply for our atomic masses.
Oh, you scared me.
I did not know.
Oh, I just swapped the.
Add them up.
68.
Yeah, I swapped it. I just swapped it.
No, that's the atomic mass. I'm going to show you the rest on here. If you want to do the rest for practice, watch the video online. New high quality microphone. The audio quality is going to be through the roof. And then you can check these and then you can do your homework.
Oh, basically I got it. I just messed up one.
Basically? How about basically?
Basically, I'm gonna fail the quiz.
Basically, you're going to do fine.
I bombed on that.
What?
What do you mean by
Turn off the-
I bombed that?
Last time.
Wait, I have a question.
And
Yeah.
Is it easier than that?
No.
That's
Why would it be easier?
Seriously!
That's not hard. You just got to do some math. You got it.